The general conviction among most experts is that the speculation of how things came to be stays the essential clarification for the early times of the universe. This hypothesis joins the development of stars, planets, and, in this manner, forward life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang offers an enlightening assessment concerning what could have occurred at first. The universe was initially thick in a short space, more thick than a pinhead, with particles densely packed. From this moment, a giant explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of tremendous history. In any event, insensible information, it has set off creating quirks with the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, experts assessed that its insight would confirm the hypothesis of the universe's starting point. Unfortunately, after only 1 year in space, the telescope stunned experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's dazzling limits have uncovered innumerable galaxies going as far back as a period so old that it challenges how we could interpret the universe's beginnings. This discovery has ignited a serious examination concerning what existed before the Big Bang. One crucial point in time in this mission occurred when cosmologist Rohan Naidu, working with data from the telescope scope, suddenly found a galaxy from just a short time after the Big Bang, making it the most distant universe ever. Naidu's discovery sent shockwaves through established experts, highlighting the striking abilities of the James Webb Telescope. Its colossal target to alter our viewpoint on the universe has barely begun, promising to reveal stunning insights into the earliest seasons of the universe's existence. This period, scarcely focused on in advance, holds the key to understanding the development of the first stars and galaxies. The telescope's discoveries have clashed with crucial theories, uncovering galaxies with characteristics surpassing past assumptions. This unprecedented flood of early galaxies has sparked a storm of scientific inquiry, testing subject matter experts to reconcile these discoveries with existing hypotheses. As scientists catch up with these revelations, they face key questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's benefits, which are clear, it is found 1.5 million kilometers away from Earth, protected from cosmic interference and cooled to approach absolute zero by its tennis court-sized sun shield. The telescope incorporates a huge, fragile mirror and stunningly delicate instruments designed to reveal details of the early universe, previously confidential. This period, known as the Cosmic Dawn, occurred around 200 to 300 million years after the Big Bang, marking the event when the first stars and galaxies began to form. The process by which this unfolded remains a subject of great inquiry, with speculations ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they may interpret these intricate parts. By studying these ancient galaxies, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new revelations. From the outset, the telescope was expected to observe only a few weak and small galaxies in its pilot studies. However, reality has far surpassed these expectations. The telescope's initial photos of the distant universe uncovered an abundance of galaxies with ages, sizes, and brightness levels that defied all assumptions. This shocking surge of early galaxies has triggered a race among space researchers to establish new standard records for the earliest known massive galaxies, with new discoveries arising continually, leaving traditional specialists in awe. Following the James Webb Telescope's revelations, subject experts and onlookers have rushed to study the existence of these surprisingly advanced early galaxies. Some have speculated that errors in the telescope's interpretation of massive observations could be responsible for these surprising discoveries. That said, the consensus remains that these revelations represent a paradigm shift in how we could interpret the early universe and offer exciting glimpses into the potential for immense development. The new discoveries from the James Webb Space Telescope about galaxies have raised significant questions about the nature of the universe and tested the assumptions of standard cosmological models. While some specialists are examining whether these insights can be reconciled with existing theories, others propose that they may be the first signs that the universe is much more complex and strange than previously imagined. The essential question in play is our fundamental understanding of how the universe we know emerged from primordial chaos. The early revelations of the JWST could reshape our basic notions of cosmic history, uncovering insights not just on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFan, senior scientist for science and exploration at the European Space Agency, puts it, "You build these machines not to confirm theories, but to break them. You just have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At that time, G. Weir, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, Weir and a small team began laying the foundation for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to see in the infrared range, allowing it to peer much deeper into the universe. This ability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold, star-like mirror, the JWST became the premier instrument for uncovering the secrets of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was once believed to be a void patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of investigating much further into cosmic history. After 20 exhausting years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready for its most crucial year of scientific observations. Early projects, such as the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge traditional cosmological assumptions. These stunning discoveries highlight the importance of pushing the boundaries of scientific inquiry and showcase the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to investigate JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which usually takes months, experts chose to share their discoveries on preprint servers like ARP14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new form of peer review to take place through online platforms like Twitter, where established specialists could quickly discuss findings. Rohan Nada described this process as science by press release, and the ensuing storm of discussion was both intense and remarkable. However, there were concerns about the potential drawbacks of this rapid dissemination of results. Klaus Pontypool, a JWST project researcher at Sky, cautioned that while the fast sharing of results facilitated quick dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most specialists is that the theory of how things came to be remains the primary explanation for the early seasons of the universe. This speculation joins the development of stars, planets, and life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang offers a convincing explanation for what could have occurred at the university beginnings. The universe was densely packed into a space smaller than a pin head, filled with densely packed particles. From this moment, a huge burst of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history. However, changes in scientific data have led to developing abnormalities with the assumptions of this theory when NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built. Analysts estimated that its observations would support the theory of the universe's origin. Tragically, after only 1 year in space, the telescope astonished specialists with its ability to peer deeply into the universe's past. The James Webb Space Telescope's amazing abilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked a serious examination of what might have existed before the Big Bang. The revelations brought to light by the James Webb Space Telescope have prompted not only excitement but also significant questions about the limits of our scientific knowledge as scientists continue to process the data streaming in from this groundbreaking instrument. They have been forced to reconsider some of the fundamental assumptions that have governed the study of cosmology. These findings have shown that the universe may be far more intricate and mysterious than anyone anticipated, with the potential to rewrite entire sections of scientific understanding. With its unprecedented capability to look back into the past, the James Webb Space Telescope stands poised to deliver insights that could alter the way we understand the cosmos forever. One of the more fascinating aspects of the JWST discoveries is its ability to capture the light from galaxies that formed during the first few 100 million years after the Big Bang. This period, known as the cosmic dawn, marks the moment when the first stars and galaxies began to emerge from the dark void that character is the universe. Prior to that, before the JWST, our understanding of this era was largely theoretical, with only indirect evidence available through other telescopes and observations. Now, however, the James Webb Space Telescope is offering direct views into this ancient past, enabling scientists to examine galaxies at a scale and resolution that were once unimaginable. The galaxies uncovered by the JWST appear much more advanced than previously thought possible at such early stages in the universe's history. Some of the most distant galaxies observed by the telescope seem to have properties that were not expected to emerge so soon after the Big Bang. They appear to be more massive, more evolved, and more structured than models had predicted for the early universe. This discovery has sent ripples through the scientific community, forcing cosmologists to revise their expectations about how galaxies formed and evolved in the early universe. The newfound galaxies could be part of an entirely new paradigm in cosmological theory, one that challenges long-held ideas about the timeline of cosmic evolution. One of the key challenges in studying these early galaxies is understanding the role of dark matter and dark energy, two mysterious forces that seem to drive much of the universe's behavior. Dark matter, which cannot be directly observed, is thought to make up a significant portion of the mass in the universe, and it plays a key role in the formation and structure of galaxies. Dark energy, on the other hand, is believed to be responsible for the accelerated expansion of the universe. Both of these entities remain largely unknown, and the JWST ability to peer deeper into the universe's history may offer new clues about their role in shaping the cosmos. The study of early galaxies also provides insights into the fundamental physics of the universe. By analyzing the light from these distant galaxies, scientists can gather information about the composition of the universe in its infancy, including the types of elements that were present in the earliest stars. These observations could offer a better understanding of how the first atoms and molecules were formed and how the processes that led to the creation of stars and galaxies began. This kind of research is essential for understanding not only the origins of galaxies but also the very foundations of matter itself. Another key aspect of the JW's mission is its role in examining the atmospheres of exoplanets or planets that orbit stars outside our solar system as scientists search for signs of life elsewhere in the universe. The telescope's infrared capabilities allow it to study the atmospheres of distant exoplanets in unprecedented detail. By analyzing the chemical composition of these atmospheres, scientists hope to detect potential biosignatures, chemical markers that could indicate the presence of life. This research is still in its early stages, but the potential for significant discoveries is immense. With the James Webb Space Telescope, we may be closer than ever to answering one of humanity's most profound questions: are we alone in the universe? In addition to its scientific impact, the James Webb Space Telescope also represents a triumph of human ingenuity and collaboration. The telescope's development was a global effort involving scientists, engineers, and technicians from around the world. The project faced numerous challenges over its long development timeline, from design hurdles to budgetary constraints. But the successful launch and deployment of the JWST stands as a testament to the persistence and dedication of those involved. The telescope's ability to reach and operate at such extreme distances and to function in the harsh environment of space speaks to the remarkable advances in technology that have made these discoveries possible. As the data from the JWST continues to pour, and scientists are beginning to ask deeper and more philosophical questions about the nature of the universe. What does the discovery of more advanced early galaxies tell us about the processes that govern the formation of the cosmos? How can we reconcile these new findings with our existing theories of cosmology, or do we need to rethink those theories entirely? The insights gained from the JWST are already transforming our understanding of the universe, and they will likely continue to do so for years to come. The telescope's findings challenge the idea that the universe unfolded in a linear, predictable fashion, suggesting instead that it is a much more dynamic and complex entity than previously thought. The discoveries of the James Webb Space Telescope are not only reshaping our understanding of the early universe, but are also leading to new areas of exploration as we continue to study these distant galaxies and exoplanets. The potential for groundbreaking discoveries is limitless. With each new revelation, we move closer to answering some of the most profound questions about our existence and the nature of the universe. The journey to understand the cosmos has only just begun, and the James Webb Space Telescope will undoubtedly play a pivotal role in shaping the future of space exploration and cosmology for generations to come.